All right, today's the 25th. Okay, for the graph of tangent, where are the normal starting and ending asymptotes?
Negative pi over 2 and pi over 2.
Okay. So all of these things that are happening inside with x are going to change those starting and ending asymptotes. So I need to isolate x. What do I need to do?
Add pi over 4.
Add pi over 4. Add pi over 4. That gets rid of that one. All right. What do you need in order to add fractions together?
Common denominator.
Common denominator. So this becomes 2 pi's over 4 plus 1 pi over 4. Yeah? Is that right?
Yep.
Okay. Which gives me 2 pi's plus 1 pi is 3 pi's over 4. Over here, we had negative pi over 2 plus pi over 4. I got to multiply this fraction by 2, top and bottom.
2.
That becomes negative 2 pi over 4 plus 1 pi over 4. Which gives me negative pi over 4. Now, those are asymptotes at negative 1 pi over 4 and 3 pi over 4. Those are asymptotes. To actually graph the tangent function, we need to find the midpoints. What is halfway between negative pi over 4 and 3 pi over 4? Remember that?
Yes.
Okay. So half of 2 pi's over 4, which would be pi over 4. Okay. What's halfway between negative pi over 4 and pi over 4? 0. Okay. What's halfway between 1 pi over 4 and 3 pi over 4?
2 pi over 4.
2 pi over 4.
Yeah.
Yeah, that makes sense. Okay. Tangent goes how? Toes to nose, low, middle, high. Toes to nose. If you were labeling over here in vertical land, this would be a 3 and a negative 3. But that's a great graph. That's fine. It's not really vertical land. It's more like slanty line land. Yes, sir.
So I'm just wondering right now, what you said it equal to negative pi over 2 and pi over 2 originally, rather than 0 and 2 pi.
Tangent is a different function.
Okay.
So, I don't have a calculator. Hold on, radians. Okay. So if I were to graph the tangent function, oops. It has asymptotes. That's what these vertical lines are. They're really just asymptotes. And if I trace and type in negative, I don't know where pi is. There it is, over 2. So negative pi over 2, it get error. That's undefined. So that's right here where the normal asymptote is. Okay? So these starting and ending values that we use for all of our functions are based on the regular function. So in this case, normal tangent of x starts at negative pi over 2, or has an asymptote at negative pi over 2, and then another asymptote at pi over 2.
Okay, thank you.
What were the normal asymptotes for cotangent? 0 and pi. 0 and pi. So tangent, we use negative pi over 2 and pi over 2. Cotangent, we use 0 and pi for those asymptotes. What do we use for sine and cosine? 0 and 2 pi. Good. 0 and 2 pi. So sine and cosine are nice. They start at 0 and end at 2 pi. for one regular period, okay? And those are the things that you're going to have to remember. Most of the rest of the stuff is pretty much the same, okay? Okay, today we are graphing secant and cosecant. And the nice thing is we get to graph the reciprocal function first. So we're going to go back to graphing sine and cosine. And once you graph that curve, then it's really easy to graph secant and cosecant. So what I'm going to show you right now is in your calculators, we're going to just start with sine. I want you to graph sine of x and y1. And in y2, we're going to graph cosecant. How do we type in cosecant of x?
1 over.
1 over sine of x, okay? So let's go ahead and have a looky-loo at that. So I'm going to look at sine of x and then 1 over sine of x. Yeah. Crazy. I don't like this window. Let's see if I have a different. Oh, that's terrible.
Oh boy.
Original square integer? No, I don't know what that means. Ah! Sorry, I haven't played around with this. No, that's not good either. Okay.
What is that?
Oh, a weird, sorry. Trig. Hey, there's a good, let's try that one. Okay. Oh, there's an excellent window. Okay. Almost good. Okay, I want to go from -4 to +4. Okay. All right, there you go. So you should use a trig window when you're graphing. All right. So this is pretty good. Most of you probably see something like this.
Yeah.
Okay, so sine of x, here's our sine curve right here. Middle, high, middle, low, middle. Okay, do you see that? Okay. And so what happens wherever, if we're thinking about our unit circle, let's look at 0 right here. What's the ordered pair at 0?
1, 0.
Okay. And so what is the sine value, at 0, not theta, sorry. What is the sine value at 0 radian?
1, 0.
0. Right there. Sine, cosine, sine. Okay. Okay. So what's cosecant at 0 then?
Undefined.
Yeah, because you'd flip this over. Right now it's 0 over 1. We flip it and it become 1 over 0, which means it's undefined. And so what happens at 0 is we get a vertical asymptote. Everywhere it crosses the midline, in fact, we get a vertical asymptote for cosecant. All right? So everywhere we have a 0, a midline, we get an asymptote. And so that's what we're doing today. We're going to graph the reciprocal function, draw in some asymptotes wherever it crosses the midline, and then all it does is flip out into these parabola shapes. And I can talk about why, but it's really boring. But it has to do with just flipping your fractions. So let's just do a few and see what it looks like. Sample 1, sketch the graph of the function, state the domain, range, and asymptotes in. Maybe we will, maybe we won't. Sketch the graph. So what I'm going to do is I'm going to use light blue and graph our reciprocal function. So I'm actually going to graph not cosecant, but what is its reciprocal? Sine. Sine of pi x plus 1. What's inside the function with x?
Pi.
Pi, just pi. Not the 1. All right, so in case we weren't very clear on that. Okay, so what we're going to do is we're going to graph this sine function first. It has has a midline. What's the midline? 1. What's the amplitude? 1. And we need to figure out the starting and ending values. Where does the normal sine function begin and end? 0 and 2 pi. 2 pi. So all the stuff with x is going to adjust the starting and ending values. So how do I solve for x? Divide by pi. All right, so 0 divided by anything is 0. 2 pi divided by pi is 2. All right. So I'm first going to go ahead and draw my midline. My midline was 1. So there's my midline. I'm going to make it dotted.
I know.
It's totally messed up. Oh, okay. My amplitude is 1, so how high does my sine curve go?
1. Wait, it starts at 1. 2.
2 and 0. Okay. And then on my horizontal axis, I'm starting here at 0. It ends at 2. What's halfway between 0 and 2? 1. What's halfway between 0 and 1? 1/2. And between 1 and 2?
3 halves.
3 halves.
You got this, choice.
All right. Now, what is the sine song? Middle, high, middle, low, middle. Okay, excellent. So we can, here is our sine curve. Now, is this curve really here? No, it's not really there. It's a reference curve, okay? Now, to draw cosecant, we need to add in asymptotes. Vertical asymptotes occur at every crossing of a midline. So everywhere that we cross, our graph crosses the midline, it becomes a vertical asymptote. So we have a vertical asymptote at x equals 0. Where's another vertical asymptote? 1 and 2. At x equals 1, we have a vertical asymptote, and at x equals 2, we have a vertical asymptote. So where else might we have vertical asymptotes?
3, 4, 5.
X equals 3 and 4 and 5. And in fact, all of our vertical asymptotes occur when
Integers.
x equals k, where k is an integer. Very good. All right. That's all I care about right now. Okay.
Scoot out a little bit.
Sorry. Yeah. Sorry about that. Okay. It's very dim, isn't it? Yeah. Fine. All right. So now, in order to actually graph cosecant of cosecant of pi x plus 1, all I have to do is go to my maximum on my sine curve and just flip it out, and it turns into this parabola type shape. Go to a minimum and flip it down, and it becomes a downward facing like parabola type shape. That is one period of the cosecant function. That's it. The black graph is the cosecant graph. Yeah.
You want us to just like put all of that on the graph?
It's fine.
So the parabola doesn't have to be like anything specific and crazy. You just have to make it kind of like
Make a U.
Like
Make
a
a
decent
U
U.
shape.
A
Yeah.
decent U
Yeah.
or a...
Yes, in the homework, I want to see your sine curve. But no, it's not really there. You can, if you just want to do the dots, you can. The middle, high, middle, low, middle dots is fine. And then just your maximums turn up and the minimums turn down. Asymptotes, yes. Okay.
Never mind.
You got it?
Figured out which one was midline.
Oh, okay. All right, so now let's look at the second one. Y equals negative secant of 2x plus pi. All right, what are we going to graph instead?
Cosine.
Cosine. So we're going to graph y equals negative cosine of 2x plus pi. So to get going, what's the midline here? 0. What's the amplitude? 1. But what does the negative do?
Flips it.
Flips our cosine song. So we want to be aware of that. And our cosine usually starts at 0 and ends at 2 pi. Sorry, I guess you didn't know where I was going with that. That's okay. All right. So all this stuff inside with x causes changes to the starting and ending point. And so we need to figure out what happens. What should we do to solve for x?
Subtract pi.
Subtract pi. 0 minus pi is?
Negative pi.
We get a 2x in the middle. 2 pi minus 1 pi.
Pi.
And then we need to,
Divide by 2.
so we get x is between negative pi over 2 and pi over 2.
Just like
All right.
tangent, right?
But yeah,
It's
kind
a
of.
tangent.
All right, so we had a midline at 0, an amplitude of 1, and my x-axis is going from negative pi over 2 to pi over 2. Again, I don't care where your y-axis is. It's not important. What is halfway between negative pi over 2 and pi over 2?
0.
0. Okay, good. All right. It's better there. Okay. What's between negative pi over 2 and 0?
Negative 3 pi.
Negative pi over 4. Yeah. So if you're curious, that what's halfway between negative pi over 2 and 0? It's half of negative pi over 2 is negative pi over 4. Okay. All right. And again, halfway between 0 and pi over 2 is pi over 4. Okay. So what is the flipped cosine song? Low, middle, high, middle, low. Okay. So here is our cosine curve. I'm going to make it go a little bit more. You don't have to label it. I'm just continuing it a little more. And where do we have asymptotes for our secant function then? Nope.
Whenever it hits one of the outer ones, like the minimum or maximum.
Nope.
Whenever.
Where they hit the midline. Where we hit the midline. Where we hit the midline is where the asymptotes occur. So this graph only gets 2, although I have one right here, which I'll draw in as well, because I extended my curve a little bit more. So there's my asymptotes, and then any maximum flips out into an upward U, and a minimum becomes a downward U shape. Like that. Okay?
All right.
Is that good enough?
It's
I want to check this in my calculator. Typing these in can be hard to check in your calculator. This is -1 times the secant of all this stuff. So I'm thinking that that's -1 times 1 over the cosine of all of that stuff. Then -1 times 1. So I'm going to write in my calculator -1 divided by the cosine of 2x plus pi. So exit, delete, delete. All right, so -1 divided by the cosine of 2x plus pi.
Oh, it's.
Nice. Okay. All right, and so there is what the calculator's graphing. And what I want to do is check some points. So for instance, here's a point that I could check. That point is 0, 1. So I can trace 0 and it gives me the 1 right there where I want it. I could also check this point right here, which is pi over 2 and -1. So I'm going to type in pi divided by 2 and hit enter, and I do get -1, and it's right there on that little downward facing U. So graphing on the calculator and using trace to check your ordered pairs is a great strategy to make sure you did it correctly. Do you guys have questions for me? Where do you draw the asymptotes? Right across the midline. The midline. All right, very good. You guys have CP30, same page as yesterday.